Just the printed circuit board in and of itself, I don't think a lot of people realize how much work goes into making that piece. Everyone always has the interest in semiconductors. I mean, don't get me wrong, that is a very respectable field and it has a lot of its own challenges. But even just the board itself has a whole different set of challenges that still need to be addressed.
Hello, everyone, and welcome to the Altium On Track podcast. I'm your host, Zach Peterson, and today I'm happy to be speaking with Christopher Bonsell, chemical process engineer at Chemcut. If you've been paying attention to iConnect 007 at all, then you may have read a couple of his articles. I think they're very interesting, and of course, they've given me an opportunity to learn about some of the process engineering that goes on in PCB manufacturing. Chris, thanks so much for joining us.
Hey, thank you for having me on. Also, it's great to hear that you enjoy the columns I put together. It's always
Yeah,
good to get some feedback from someone that actually reads them.
yeah. Well, I've said many times, one of my New Year's resolutions, I guess, for 2022 was to learn more about manufacturing, and I continue to be impressed with the expertise that goes into it. In fact, I think there's a bit of a perception that manufacturing is something, especially like in a technologically advanced area, that manufacturing is something where you walk into a room, you flip a switch, and all the gears start turning, and then finished products spit out the other end of a line. And I'm sure it's not actually like that.
Yeah, of course. Yeah, there's a lot of inputs that have to go into manufacturing. A lot more than that really meets the eye. That is for sure.
So, as a chemical process engineer working in a manufacturing facility, what is it that you're actually doing all day?
Okay, so first let me explain what Chemcut is, because it
Yes.
does tie into a lot to what I do. So Chemcut is a manufacturer of wet processing equipment. So in relation to manufacturing of printed circuit boards, we make the equipment that etches, develops, and strips all the printed circuit boards. Now, what I do as a chemical process engineer is a little bit different from what most process engineers would do. I'm a little bit more on the research and development side of things. What I mostly do is I will actually run tests to try to improve our wet processing equipment. But another thing that we do is some of our customers, if they want to see how our equipment works, they'll actually send us some samples so that we can run tests for them. And since we have probably the most knowledge in how to actually work our machines and what processes would be best to achieve their goals, we are the ones that will take their samples and try to actually like make it happen. We kind of do a little bit of a proof of concept for them.
So, when you say samples, what exactly do you mean?
Okay, so for example, sometimes companies will send us let's say, an 18 by 24 panel of copper with a Kapton in the middle. So they'll tell us they want to achieve certain parameters on their lines and spaces, and we'll run them through our machines and see what we can do.
I
So
see. So they may be looking for a specific slope on the edge of the trace or something
exactly.
like this.
So by samples, I'm essentially saying panels that they want to get certain parameters on.
Okay, so this could be a materials company, someone like this.
Exactly, because Chemcut not only does stuff inside of the printed circuit board industry, we also are involved in the chemical machining industry, which can go into a lot of other different sectors. So if people want to make small sheet metal parts, or if they want to make just like normal signs or like printing equipment, like you can do that.
Okay, interesting. Um, Now, the customers that are buying your equipment, I mean, it sounds like larger EMS companies, or is it all the way down to like the small board houses that maybe do fast run prototypes?
It really is a wide range. It could be the big board manufacturers, and it can also be little mom and pop shops. We really serve a wide range of customers.
And I mean, are you providing support all the way down to the process level for those customers?
Yes, we are. A lot of the times, our customers will actually like send us emails, or sometimes we'll even actually go out to visit their facilities to help them with their process.
That was the
Because a
next
lot of
thing I
people,
was going to ask, is if you're
yeah,
actually making house calls.
yeah, a lot of people, surprisingly, whenever they get involved in the industry, they don't know as much as you would think they would getting into the industry. So a lot of times they know what they want to do, but they need to know the steps to make the product. And that's kind of where we come in.
Okay, so you're really guiding them through the automation part of it, and of course, and
Yes,
I think with the process engineering in this respect, it's more teaching them, I guess, the right mix of inputs into a chemical etcher system in order to ensure they hit their parameters.
exactly. And there's also some other factors too. Like sometimes it's not just running a machine and making products, it's also about taking care of the equipment.
Hmm.
And that's a factor that a lot of people seem to neglect. But we always try to hound the customers like you got to take care of the equipment. If you take care of the equipment, it'll take care of you.
Oh, sure. I mean, there's a lot of capital that gets invested into some of this equipment, and
Hmm.
so of course that comes with a maintenance expenditure. And yeah, I totally agree with you. The maintenance is what keeps you competitive.
Yeah, for sure.
So, I mean, do you see the capabilities of some of this equipment degrade over time if it's not properly maintained?
Yeah, if it's not properly maintained, you will start to see some issues. It's more like you'll notice some things are not coming out the way that they should be. Sometimes you can get matters where like some parts need to be replaced very soon. Like the lifetime of some certain parts will actually like expire. And then you'll have to order more parts and it's just a whole domino effect.
I
And if
see.
a lot of your parts are falling apart in your machine, that translates to, well, your machine not lasting overall as long.
Sure, sure. But I mean, in the chemical etch machine, I mean, is the inputs that you're actually putting into the machine degrading it over time? Is what it sounds like.
Yeah.
Okay.
Like whenever it comes to maintenance, it really is like if you're not keeping it clean, if you're not frequently checking on certain parts, it'll just kind of like I said, it's a domino effect. As things get worse, if they don't get the attention they need, it'll get much worse much later.
Mm-hmm. Uh-huh. Yeah. So with some of that diagnosis of maybe what needs to be maintained or what needs to be repaired, yeah, I'm going to assume that you guys also help with that kind of thing. This is an
Oh
issue.
yes.
So these issues they can call up, the company, whether it's Chemcut or another company. They can call up the
Yes.
company and get help with this diagnosis, and then of course ordering spare parts and all of this.
Yes, very much so. We actually have a whole team of field service. Um, uh, their entire job is just to make house calls with customers. If they're having an issue, they'll come visit. We even do scheduled preventive maintenance. So if you want to make sure that your equipment's running well, we'll also do that for you.
Okay. Uh, this this sounds like it mirrors a lot of what goes on with semiconductor manufacturing equipment. And in fact, when I was younger, I almost got a job as a technician before starting graduate school. But I almost got a job as a technician working on semiconductor equipment. And it was just like you said, you have to go out and make house calls. You have to get clearance to go to a site. You have to learn how to work in a clean room because you're probably going to be maintaining something in that room.
Yeah, that's for sure. I don't necessarily know too much about how semiconductors are made, but from what I've seen, it is very similar.
Yeah, I think we get a lot of our cues in what we do with PCBs from the semiconductor industry. At least that's what was said to me from another guest.
Mhm. Yeah, very interesting.
So anyone that's watching this right now is probably going to look at you and say, "You're pretty young." Um,
I get
I
that a lot.
I know I'm older than you, um, but one of the things that I'm always happy to see is when we have younger people who are getting into this industry and getting into manufacturing. And I'm always interested to know people's journey as far as, not only how did they get into electronics, or how did you, kind of start yourself down this career path, but why manufacturing and maybe not some other area of technology.
Okay. So my journey kind of begins back whenever I was in college. So overall, I really didn't have a good idea of what I wanted to do with my chemical engineering degree. So I got involved in some research, and that kind of involved manufacturing or just trying to create some prototypes for a certain separator. But whenever I was going out into the workforce, whenever I started looking for jobs, I was having a little bit of difficulty. I didn't have the internship experience that most other students had. So I spent a good bit of time looking around for jobs. And one of the jobs that I came across was actually recommended from a lady that I used to work with. She said that her husband worked here at Chemcut and said that, they're looking for a chemical engineer. So I gave my resume, sent it to him, and it all worked out pretty well. So really in that situation, it really was just about like, who I know. But overall, as I started working here, I didn't realize how much in depth this really gets. I never really realized, whenever it comes to making things like printed circuit boards, that there is a chemical engineering aspect to it. Whenever I was applying, I never saw that, well, I noticed that process engineering has a very wide span. But whenever it came to like electronics, I always kind of assumed that process engineers in electronics, they want electrical engineers, not chemical. But I was very wrong on that. And now, like, I learned that whenever I came here. But as I kind of worked here, so around about a year after I got hired at Chemcut, I went to the IPC show, so Apex Expo.
Mm-hmm.
And then I started talking to some people there, and my interest just grew. And honestly, like going to Apex really flipped around my career a little bit and really opened my eyes to what there is in this industry.
Well, just in terms of the depth of capabilities that are involved in all these different areas within the industry.
Yes, it really is about just the overall depth of it, and also the amount of what's the word I'm looking for? How much more progress there needs to be made, how much more work there is to be done. Because I feel like even people that are aware of our industry, they're not fully aware of the actual challenges it comes to when it comes to manufacturing things like printed circuit boards.
That's very interesting that you say that. Whether someone is technical or not, I don't think that people associate printed circuit boards with higher levels of technology or even with the word tech. In fact, if you go out to a layperson who maybe is not technical and you ask them, what is tech? They're going to say like Google and Facebook and,
Yeah.
these software companies that they know a lot about. And they're going to say, well, my iPhone, stuff like that.
Mm-hmm.
Um, what we do with circuit boards is kind of in the background, enabling everything, and people don't realize it, or they're just not conscious of it.
Yeah. Just the printed circuit board in and of itself, I don't think a lot of people realize how much work goes into making that piece. Everyone always has the interest in semiconductors. I mean, don't get me wrong, that is a very respectable field and it has a lot of its own challenges. But even just the board itself has a whole different set of challenges that still need to be addressed.
Yeah, when I was younger, and when I was in university, there was never any discussion of the circuit board at all. I mean, even in like an electronics lab class, like everything was breadboards, and you just cared about wiring logic gates up to each other to make sure that this thing you were building would work. And then when you start talking about like design and manufacturing, it was constantly on the challenges with semiconductors and getting over the next hump of Moore's Law, things like that. That's what everybody talked about. And I was, I was in school like at the tail end of the PC revolution. So this is right around the time that like literally everybody had a PC with the big CRT monitor in their house. And so
Mhm.
that I think it's understandable that at that time everyone was focused on chips. The Intel
Yes.
Inside campaign was like that. Intel Inside was a household thing. Everybody, knew the little jingle, and so that's what everybody focused on. And no one really cared about the circuit board. And I almost feel like we're still like living with the remnants of that time, even into today.
I fully agree. And part of the whole idea of, just taking on Moore's Law and just trying to get that next improvement in computing power, I feel like has really overshadowed some of the challenges that occur in this industry. Like, I feel like a lot more people would be interested in this kind of manufacturing if they were just aware of some of the technical issues that we have to try to overcome, some of the hurdles that we have. And so whenever I'm writing my columns, I like to try to like highlight some of those issues and maybe raise some more interest into it.
I totally agree. I absolutely agree because you just mentioned like the grand challenge, right? Of like, Moore's Law at the time when I was younger was the grand challenge. Um, I think when you communicate the challenge of Moore's Law to people who like to solve complex problems, that's where their focus goes and that's where their energy goes. And they say, well, this is such a amazing thing it's very consequential to technology and human development. I mean, I want to focus on that. And so I think it's natural that when you illustrate the challenges and opportunities in some of these areas, it really drags students in, but it is at the expense of other areas that are very important supporting technologies.
Mm-hmm. Very true.
So was that kind of the experience that you had when you were younger at university? Because I ask this because there's a little bit of a time delta between my experience and your experience, and so I'm wondering
Yeah.
how long that has persisted and if that's really still the case.
Yes, I'll admit that is still pretty true right now in the university. Whenever I was taking computer science, that is whenever I was first really introduced to Moore's Law and what it really means. But outside of that, I never really came across it. I knew some of my professors were involved in some research and development for semiconductors, but that was all I ever really knew about. I never got involved in that research, and I didn't really have like anybody I knew that was involved in that research either.
So I mean, on the chemical processing end and bringing it back to circuit boards, I mean, can you ever see a time where we start pushing circuit board design to smaller and smaller line widths on this kind of, I'm going to call it an arbitrary, doubling of density on boards over a certain time period, and that just becomes this, arbitrary milestone for the industry going forward?
Oh, yes, I certainly do. Well, the problem here is that we really need to get more people with a just normal chemistry background getting involved on this because it really is a chemistry issue. So, one of the things that I'm very interested in is trying to improve the etch factor. So, currently, whenever we're etching printed circuit boards, we have a very limited etch ratio. So, for every, let's say, units of etch downward, there's always going to be a give to the etch sideways. And we have to get that ratio really nailed down if we want to get to like doubling the definitions of our printed circuit boards. But we're very limited to it based on the chemistry. And that is where we need the chemist involved. One thing that I did a little bit of research on that really interested me, and I talked a little bit about it in one of my columns, was that we got pretty close to it at one point in printed circuit board manufacturing, and it was called the Peri etch process. It's a very old process that probably no one's heard about, but what's funny is I have a printed copy of the handbook from the Peri committee that developed this, and it was given to me by one of my colleagues. And I was just looking at it, and we had pretty straight sidewalls whenever we were using this process. But the problem was with that etch process was that it was a little bit difficult to maintain, and also it was using the wrong etchant. It was using an etchant called ferric chloride, which is not normally used in copper etching, but this process was made for copper etching. So you don't get the optimizations you get with other etchants in the industry, but you did get the straight sidewalls. So it makes me think that it is very much possible for us to do that again, but with the right etchants that we want. it's going to take a little bit of time and research.
So what do you think is blocking everyone from, I guess you could say, focusing their efforts collectively across different companies to maybe moving towards adoption of a process that gives you that type of etching result? What's the big blocker? Because it seems like the semiconductor industry got really good at doing these types of collectivized yet distributed efforts towards higher and higher densities.
Yeah.
And we of course look at this and say, scaling and Moore's Law and whatever other scaling laws are out there as kind of the benchmarks for what targets companies should hit. And it's like everyone just does it, you know?
Hmm.
Why don't we have that in printed circuit boards?
Well, I think from the very base level, it comes down to the interest that is actually involved in printed circuit boards. There's not a lot of chemists that are going to be interested in printed circuit boards, so they're not going to put their focus towards that. And whenever they get involved in the industry, there is a little bit of a thing that I've noticed in the industry that a lot of people, they're not exactly susceptible to change. A lot of it is just doing things as we always done it kind of attitude.
Is that an age problem?
I kind of want to say yes, but I mean it really isn't because people my age can be still susceptible to that kind of thinking.
Okay, that's fair. I guess that was a little stereotypical of me to say that, but I think there is maybe a little bit of a propensity for, once you get older, you get a little more set in your ways, and it's you kind of take a if it ain't broke, don't fix it attitude
Hmm.
towards processing.
I mean, if you are manufacturing many circuit boards, maybe that's another reason why you don't want to change it up so much. Because if it messes up, then that's a lot of you know product you have to remake.
Oh, sure. I mean, you know what works, and you're taking the lowest risk path to ensuring that whatever is coming in the door is going to get built with highest possible yield so you can maximize profit. I mean, I understand that approach. Um, I think maybe we're just a little too risk averse in this industry
Yeah,
sometimes. I mean,
I mean that,
the
that makes
semiconductor
sense.
industry regularly bets the entire company on what the next big thing is going to be, and they go for it. In fact, many of the I think it's been described repeatedly. Many of the advancements at companies like Intel have been made by literally betting the company in terms of the capital expenditure and the investment involved in getting to that next level of processing capability. They're betting it all, and it's paid off over and over again. And we don't do that, I guess, in printed circuit boards.
Yeah, no, I mean that does make sense. I haven't really heard too many um, um, cases where a printed circuit board company was trying to take a little bit more of a risk in their etching chemistry just so they can get slightly better, sidewall etching. It's just I could see why some companies wouldn't do that, but maybe that is what we need.
Well, maybe that's a scale issue. The just the size of the companies involved
Hmm.
in making those investments. Like if you have the scale as a company to divert, let's say, $100 million to this big grand investment, if you have enough scale, that $100 million is, inconsequential. But
Yeah.
if you're like the typical PCB manufacturer, that's a lot of money
Hmm.
relative to your income. Yeah, so
Yeah. Very.
I think that's a separate issue involving excuse me. I think that's a separate issue involving, how the industry has evolved over the last 20 years with a lot of the big players, going overseas and then a lot of the shops closing down, and it's kind of you got, you know, two sides of the industry in terms of the size of the producer, right? You got the smaller rapid prototyping house, the smaller CM, and then you got these huge companies like maybe TTM, Sanmina, some of the others that handle a lot of volume, but it's all overseas.
Hmm. Yeah. Whenever I was reading in one of the copies of PCB 007, actually it's the most recent one on what was it, UHDI,
Yeah.
you know, and it's just like the idea that because of this idea that we ship so much of the PCB work overseas, we are almost fundamentally 20 years behind on the curve whenever it comes to actually like kind of focusing in on how we can actually obtain those kind of features.
You're not the first person to make that kind of remark. We had John Mitchell on from IPC. We've had Travis Kelly on from Isola. They've both made the remark that the U.S. industry is something like on the order of 20 years behind the times. And
Mm-hmm.
I think I recall reading actually in 007 that if you walk into a PCB factory today, it looks a lot like it did many decades ago.
Yeah, that doesn't surprise me. Maybe there's a little bit of a different factor now. Maybe they have a robot on the end of the machines now, but that doesn't really change too much. If you look at pieces of equipment involved in printed circuit board manufacturing from 20 years ago, it looks about the same as it does now. There's just not too much that really does change. And I think it comes back to the idea that we were talking about. We need to see more risk taking involved if we want to actually get some rapid growth.
Well, I've thought that one of the big game changers could be additive, and not just like what not like MSAP or ASAP, what
Mm-hmm.
Ameritech is doing and a lot of other companies are doing, but like fully additive printed circuit boards, or at least some sort of hybrid, like rigid plus additive type of construction on a circuit board where you can print these really unique features. You can print perfect lines. You don't have any etching. You got a lot of you lose all the material waste, and you get a lot more design freedom from that. And I've talked about this with Nano Dimension repeatedly, and they have this grand vision of eventually you can scale additive all the way up to like complete assemblies, and it almost seems like a pipe dream.
Yeah, actually, I remember. Well, I was reading I believe it was Nano's article in 007, and it really did intrigue me. But like, I still have a lot of questions. I mean, I would love to have a conversation with him.
Yeah.
I don't know how much he'd be willing to tell me, but like, I just think it would just be so insightful to see like what that vision is. Because I'm personally just I'm a little bit biased. I'll admit I'm on the subtractive side of manufacturing, so I'm team subtractive. So, whenever it comes to the whole additive manufacturing, it's hard for me to see that kind of process of like 3D printed boards. How does that scale up to high volume production? I guess that's what I'm thinking, because I'm trying to think of at least this is just based off the diagram I see. I know it's very limited, but like how does that kind of almost inkjet kind of technology translate to high volume production, like running panels through our etching machines at like high conveyor speeds. I would just like to see that. Maybe there's less faulty in it, so like if you're trying to obtain very fine features, maybe then you could justify it. But it's just a lot of stuff that really needs a little bit more. Like I would like need to do more research on.
There are higher throughput processes that are optical. So there's stereolithography, and then there's distributed light printing, and those can do 2D layers. I think the challenge though with those is that you've got two different materials, right? You've got the dielectric, and then you've got the conductor, and
Yes.
so you almost to me it seems not I'm not a 3D printing expert, but to me it seems like you have no choice but to do inkjet. So just like the structure that you're even trying to replicate as a 3D printed product, it almost pigeonholes you into this process that doesn't scale well.
Yeah.
Yeah. So I mean, this has all been really interesting, and it's great to get your perspective on manufacturing PCBs. But one thing I'm wondering, and I think is actually very important, is what can we do to get more young people involved in electronics generally, not just in PCBs? Because I asked that because I was actually reading on LinkedIn from someone who I follow that they're seeing the same kind of workforce crunch that we have in the PCB industry now propagate over to the semiconductor industry. And there's going to be a huge, lack of semiconductor process engineers and designers over the next 10, 20 years. So it almost seems like the entire industry is kind of entering this crisis point, especially as we start to reshore a lot of that manufacturing capacity, both for economic and security and all these other reasons. So what can we all do to get kids to care about this again?
I think the main thing that needs to happen here is we need to just make more of these students aware of the challenges that are actually involved in the electronics industry. The more that they're aware of these challenges that we're facing, the more interest they're going to grow. But a lot of this is going to come down to, our companies going to want to, reach out to a university and see if they're willing to, invest some money to do some research projects for them. Because once the research projects are in, then that's going to help a little bit with that growth. Once the professors are involved, the students are involved, and it just kind of grows from there.
See, I agree with you. I think that's a good starting point. And I like what you say about the challenges. I agree with that as well, because I start to wonder, if I had been maybe a bit more aware of the challenges involving PCBs when I was younger, I might have gone down a different path. I thought I was going to be a professor, or I was going to, wear a bunny suit in a clean room manufacturing chips. So that's what I thought I was going to do. And, like you said, it was communicating the grand scale of the challenges was kind of what drew me into that. So what are some of those challenges in the PCB industry that maybe, I guess, students and teachers could be more aware of to try and, pique that interest for people who like to solve complex technical problems?
Yes. I think the biggest ones right now, at least in printed circuit board manufacturing, hands down, it has to be the etch factor that I was just talking about. Trying to obtain a more straight sidewall whenever you're etching a printed circuit board. Because the moment you can get a perfectly straight sidewall from just normal etching, you can pretty much overcome some of the manufacturing processes, such as MSAP and just normal SAP. So the less plating that you have to do in printed circuit board manufacturing, the better, pretty much, because it's a little bit of a tedious process and it's expensive. So if you can find a way around that, that's going to benefit you greatly. So there's that. And also, even if it's not perfectly a straight sidewall, any changes in like how we are getting our undercutting or our sidewall etching, any improvements in that will actually benefit the entire process, because we still have MSAP and the semi-additive process. The other one that I would like to talk about too is etch uniformity, and that's a little bit more about what I focus on. And etch uniformity is about whenever you have a panel running through a conveyor and it's being sprayed on top, what tends to happen is the etching will kind of puddle in the middle, and that slows down the etching. And so whenever you're making printed circuit boards, even if you have a great sidewall etch, you're going to get hung up whenever there's a puddle effect, because no longer are you getting a perfect etch around every part of the board. Now you have more etching on the side and less in the middle. So that's kind of what I'm focusing on right now. And that's a little bit more about the fluid dynamics of etching. So yeah, I would say those are the biggest ones.
Okay, so but zooming out just for a moment, the 30,000-foot view is this is an electronics density problem.
Yes.
So the grand challenge, I guess if you want to be visionary about it, right? The grand challenge is packing more stuff into your electronics has become less of a semiconductor problem and more of an assembly and packaging problem.
Exactly. I would completely agree.
So I think this is where the PCB industry needs to take control of the narrative around density and stop leaving it up to the semiconductor guys to have that one and win on it constantly.
Yes, for sure. Completely agree.
Well, to all the CMOs out there listening, You just this is your chance. Take control of the narrative. um, and then the other thing I've thought about, because I see companies take this approach quite often, but the other thing that I've thought about is to get kids more involved in electronics, maybe at an earlier time frame, like in high school. It seems like they focus on like the cool tech of the time, but make it about electronics. And so recently that's been robotics. There's all
Mhm.
sorts of dev boards out there that you can buy, and you can buy the little motor assemblies and everything, and you can make a robot and it drives around and does stuff. Do you think that would be a really compelling way to get kids more involved in electronics?
Yes, I certainly do. Like any way you can introduce electronics or electronics manufacturing, the better.
Yeah.
Because I remember whenever I was at a young age, I was getting involved in just learning to solder, just printed circuit boards, and it's such a great time. But really, there is a lot to learn from there, and also that's just getting this pure exposure to it and seeing what actually goes into the stuff that what we use today. Really,
I think that's a great way to get kids to shift their focus from what lay people consider tech into what where I consider the real tech to be, which is in electronics. Because I mean, there's like a coding aspect to it, and so now you're making the results of the coding much more tangible because they can see the device, they can feel it, they can touch it, they can interact with it.
yes, exactly. And I think that's kind of a funny thing that occurs whenever, we are given technology. Like if you were to hand somebody an iPhone right now, I mean, they wouldn't think about all the components that are in there. They might mess around with the app and be like, "Oh, that's a cool program." But they don't think about the nitty-gritty that goes into making the full actual device. At least not unless they're a person that already does appreciate that kind of stuff.
That's true. I think most people would have absolutely no idea what goes on, or would worry even about pondering about what goes on inside of that
Yeah,
iPhone case.
exactly.
Well, this has been such an interesting discussion, and I I like what you've said about getting kids involved in electronics, and it's something that I care about. And just from one engineer to another, it's great to see young people getting involved in manufacturing. So hope to have you back again at a later date, and thank you very much for joining us.
Hey, thank you very much for having me on. It's been a great time.
Absolutely. To everyone that's out there listening, we've been talking with Christopher Bonsell, chemical process engineer at Chemcut. Make sure to subscribe to our channel. You'll get updated on all of our tutorials as they come out, as well as additional podcast episodes. And last but not least, don't stop learning, stay on track, and we'll see you next time.